Hello everybody. This is Unit 8.1. We first start this unit by doing a quick review of Pythagorean theorem. If you recall from middle school, Pythagorean theorem is one of the most important theorems discovered in mathematics and certainly in geometry in many ways. And it's not hard, but you do need to understand which side is called a leg and which side is called a hypotenuse. So here we have an example. On the left hand side we have a right triangle ABC. I should do ABC, and we use Pythagorean theorem to find the missing side of a right triangle. So it only applies to right triangles. And side A and B are called legs. And notice that it doesn't matter which side, which leg you call A, which leg you call B. You can switch the A and the B. But it does matter which side you call C, which is the hypotenuse. And that has to be the side facing the 90-degree angle. Hypotenuse. Make sure that I spell this correctly. And then the relationship is, if I take the sum of the squares of the legs, I should come up with the hypotenuse squared, right? Simple example. In example 1, the setup is x squared, which is my hypotenuse, is a squared plus b squared, and that should give me x equals 15.3. Okay. Let's do example 4. In this case, what's given is the C side and one of the leg, if we call this A. So if C is 30.5 squared, 30.5, so we need to square this, and then we use 19.1 squared is one side, and we call this side X, the second leg. So you do your algebraic manipulation, you should come up with 23.8. So let's look at number 6. It's a little bit more tricky. Let's look at number 5. We'll go a little bit slow. I have this side and this side being congruent, which means that I have an isosceles triangle. And if that's the case, this side and this side must be congruent as well. So this must be 11. So then I can do my c squared is 24 squared equals one of the legs is x and the other leg is 11 squared. So this one you should have 21.3. Okay. Now for number 6, it looks odd because it doesn't have a triangle. I have 18, 16 here, 5 here, and an x here, and I need to know x. But what's beneficial is I have 90 degrees here. And so in geometry, we haven't practiced this much, but you can add and subtract lines, and very often it's adding rather than subtracting. You can add a dotted line here that makes this parallel to this. So here I create a rectangle, which means that if the opposite sides has to be exactly the same, so which means the added line, the length of the added segment is also x, and this has to be 90 degrees. So I created a right triangle that way, and one of the legs is x, and the other leg is, if this is, whole thing is 18, and this side must be 5 because it's parallel congruent to the opposite side. So this side is 13. So it's 13x plus x squared should equal 16 squared. Okay, and x comes out to be 9.3. So in this case, the trick is you need to add a line to create a right triangle to help yourself have the ability to use Pythagorean theorem. So let's look at number 7. Number 7 is a little tricky because it has to borrow the properties we learned in chapter 6. I think it's 6.6. Those properties with respect to medians and altitudes and angle bisectors, etc. So here we are. We have one right triangle here, and I have a hypotenuse, I have a leg. So then I know I can solve for this, right? So if I call this side A, I could call this side B. And so if that's the case, let's go for B first. So I have 29 squared should equal 12 squared plus B squared. And B comes out to be 26.4. Now if I look at the smallest right triangle on the left-hand side, let me use a different color. So I use A here, and I'm looking at this right triangle here. I have a hypotenuse, which is 14, so 14 squared. I have A squared as a leg, and the other leg is 12 squared. So A comes out to be 7.2 if you use your calculators. So finally, X is 26.4 plus 7.2. That should give me 33.6. Okay, now let's look at some application problems. I'm going to leave, please make sure that you finish all the questions that I'm not demonstrating. They're fairly similar. Some of them needs to, takes an extra step, but they're not hard. So make sure you finish those, and then let's look at number 10. A roofer leaned a 16-foot ladder against a house. If the base of the ladder is 6 feet away from the house, how high up is the house does the ladder reach? So let me move this up a little. So if I have a house that looks something like this, right? I'm a terrible drawer. There has to be a door somewhere with a door handle. Actually, that's not too bad. Now I lean the 16-foot ladder against it. So now, except that my ground is not flat, but you got the idea. So I do a ladder here, and I should have some steps. There we go. And this is 16. Notice that the house, even though it doesn't look like it, that's perpendicular right there. And the base of the ladder is 5 feet away. So this base, I'm going to take this point to this point. This is 5. So in other words, I've got a hypotenuse. If I extrapolate this right triangle out, I would have 16 as the hypotenuse and 5 as one of the legs. And it's asking me how high up the house does the ladder reach. So it's asking me for the other leg. So it's simply c squared equals a squared, which I call x here, which is the height, and b squared, which is 5. And your x should come out to be 15.2. Okay? So that wasn't too hard. I'll do another one. The trick of these questions is to slow down. Word problems can be so overwhelming. I often say that it's actually an English problem, not a math problem. The math involved is fairly easy, but how to translate English into mathematical concepts, into mathematics, and reach into the right department where you store all of your information and then solve it, that's the tricky part. So let's look at number 12. Ashley jogged 3.5 miles east, then 5.7 miles south. So right here, if Ashley started from here, I call this A, and she goes east. East is this way, right? And reaches here, and that's 3.5. Then she goes south, so she goes this way and goes 5.7. How far away is she? So I call this B and I call this C. How far away is she from the original starting point, which is A? So if I call this X, and again, my right triangle is there. So now I have 2X. If I just take the sum of each leg squared, I should have X equals approximately 6.6 miles. Okay, so that's how we do these application problems. They're really not hard. Like I said, the translation is key. So slow down, take each sentence and make mathematical meanings out of it. And we'll probably move on to a second video in this unit to discuss something else about Pythagorean theorem. I'll see you guys in that video then. Take care. Bye.